Welcome to the session number 10 from the playlist of NEET Physics. The topic is the electrical field at the center of a semicircular arc. And based on this topic, I have selected one question for this session, which is written here on this board. And this question was asked in the CBSE All India Pre-Medical Test in the year 2000. So the question here is: a charged wire is bent into a form of a semicircle of radius A. If the charge per unit length is lambda, then the electrical field at the center of a semicircular arc is. So यहाँ चार options दिए गए हैं and we have to find the correct option. तो यहाँ पर एक charged wire है which is bent into the form of a semicircle. So let us say this is a wire. So when it is bent into this form of a semicircle, so it will be something like this. And then this will be its center, say it is O. So this is a semicircular wire of radius A. So the radius of this semicircular wire is A, and here the charge per unit length is lambda, that is the linear charge density here. The linear charge density वो हमें दिया हुआ है, that is equal to lambda. So now since the wire has got a uniform linear charge density which is equal to lambda, and since the radius of this wire is equal to A, then we can say that the circumference of this semicircular arc, or you can say the circumference of this semicircle, will be equal to pi A. And now here what I will do is I will just consider one segment, say DL, one segment of this arc or this semicircular arc of very small length, say DL, and which is subtending an angle, say d theta, at the center O. Now we know that in the case of a circle, if this is the radius of this circle and this is the angle theta which is subtended by the arc AB, this is the AB, and let us say this is equal to S, then S is equal to R into theta. So I will be using this formula, that is S is equal to R theta, in order to find the length of this segment DL. And this segment DL is a very small length, and this circumference of this wire is the summation of all these small segments, that is DL, and in this case DL will be equal to the radius of this semicircle is A, so this will equal to A into d theta. Now since the linear charge density is equal to lambda, so the total charge on this segment DL will be equal to lambda into this will be equal to lambda into DL, because the linear charge density is given as lambda, that is lambda is the charge per unit length. So here the value of DL is equal to A d theta, so the total charge on DL will be equal to lambda into A into d theta. So now this length DL is very small, and we will be first of all finding the electrical field at this point O, due to this small element dl. Now the electrical field, say dE, because of this small element dl, will be equal to, and this will be directed as given by this arrow. So this is dE. This will be equal to 1 by 4 pi epsilon naught into the charge, the total value of charge on this segment here, which is equal to lambda into A into d theta, divided by the distance, which is equal to this is equal to A square, because the formula for the intensity of the electrical field is equal to 1 by 4 pi epsilon naught into q upon r square, where r is the distance of the charge from the point at which we have to find the value of the electrical field. So this is the value of the E, and this will be the direction of this electrical field will be as given by this arrow. Now let us say this angle is theta. So if this angle is theta, then this angle will also be equal to theta, this one. That is the angle subtended by this by the direction of this electrical field with the diameter of this semicircle. Let us say the diameter of this semicircle, I am just denoting here as AB. So AB is the diameter of this semicircle. So theta is the angle which is subtended by the direction of the electrical field and the diameter of this semicircle. So here what is happening now, let us consider, so since this is a uniformly charged wire, therefore if there is one element dl on this side, that is, this is one part of this semicircle, this is the quarter circle, and this is a quarter circle. Now since the charge distribution is uniform, therefore if there is one element dl here in this part of this in this quarter circle, then there will be another element dl in this quarter circle. So there will be exactly another element, say here dl, if this is one dl element here, so there will be exactly one element in this part of this circle which will be exactly opposite, or it will be in front of this element dl. So because of this element dl, the electrical field at this point O will be directed like this. And now if I resolve this electrical this value, this dE into components, then I will be getting one horizontal component. So because of this element dl, the horizontal component will be like this, and because of this element dl, which is exactly in front of this element dl, so this will be directed in this direction. So the horizontal component will get cancelled out and the vertical component will be added up. This is the vertical component. So the vertical component will be added up. So the electrical field at the point O will be the sum of the vertical components of the electrical field due to all the elements dl which make up this semicircle. So the vertical component of this electrical field will be equal to, I am just writing it here as dE V. This will be equal to 1 by 4 pi epsilon naught into lambda A d theta upon A square. This vertical component will be equal to into sine theta. And now I will be simply integrating this value within the limits of 0 to pi. That is, if I move from here to here, then the total angular displacement will be equal to 180 degree. So I will be simply integrating this value within the limits of 0 and pi, and here I can I will just write it here. That is If I indicate this value, then the total electrical field at the point O will be equal to, now 1 by 4 pi epsilon naught is a constant, lambda is also a constant, and this will get cancelled out. So this 1 upon 4 pi epsilon naught is a constant, and lambda is also a constant, so lambda A. So lambda and A. This can be taken out, and I will be integrating. So I will be getting, we have to simply integrate sine theta d theta within the limits of 0 and pi. So from here, the value of electrical field intensity at the point at the center of this semicircular arc will be equal to, now the integration of sine theta will be, this is sine theta d theta, sine theta d theta, and the integration of this will be equal to minus cos theta from 0 to pi. So from here, the value of the electrical field intensity at this point O due to this semicircular arc will be equal to, now this will be equal to minus cos pi and minus plus cos 0. So this is equal to, now the value of cos pi is equal to minus 1. So this is equal to minus 1, and minus 1 will be equal to 1. And this cos 0 is also equal to 1. So this will be equal, the value of cos minus cos pi and plus cos 0 will be equal to 2. So this is equal to lambda, 2 divided by 4. This will be equal to 2 pi epsilon naught A. So the correct option here is A. That is lambda divided by 2 pi epsilon naught A. So the value of the electrical field at the center of this semicircular arc will be equal to lambda divided by 2 pi epsilon naught A. So thank you very much for joining this session. In the next session, I will be coming up with a different topic from the chapter of this electric charges and field. So till then, have a nice day. Bye.